Section 7.2, Multiplying Polynomials. We've already looked at adding and subtracting polynomials, which just involves combining like terms. Multiplying polynomials is a more complicated but often more interesting type of problem. There are a lot of different ways to approach these problems, so we're going to see a lot of different methods here today. The first method, if you have something like x plus 2 times x plus 5, where both polynomials are in parentheses, this is a binomial times a binomial, both of degree 1, we will use the distributive property. And to start with the distributive property, we're going to treat this first polynomial as an entire group and distribute that to each part of the second polynomial. What that will look like is taking x plus 2, keeping it together, and multiplying it by x, and then taking x plus 2, keeping it together once again, and multiplying by 5. Now that we've done that, we'll be using the distributive property again, this time distributing the x to both the x and the 2 in the first, and the 5 to the x and the 2 in the second term. X times x, now they can be multiplied, and x times x we know is x squared, plus x times 2, which is 2x. Even though x and 2 are not like terms, they can be multiplied. From the second distributive property, I'll get 5 times x, which is 5x, and then 5 times 2, which is a positive 10. Now I just want to make sure that everything is simplified, so I'm going to combine any like terms that I can. The x squared stays as it is. 2x plus 5x combine to become 7x plus 10. And that is going to be my final answer. What's that, you say? One method's not enough? Well, then here's another. This is an option that looks a little bit like a Punnett square that you would have seen in a biology class. If I have 2x minus 3 times x plus 5, I can use a 2 by 2 grid in a manner very similar to a Punnett square to figure out my simplified answer. The first thing that I'll do is I'll take my first polynomial and go term by term and write those on the top of my Punnett square. 2x over the first column, negative 3 over the second column. I'm then going to take my second polynomial, x plus 5, and I'm going to put that to the left of the Punnett square. Although it's not really a Punnett square, that's what we'll call it because it just is easy to remind ourselves of how to fill it in. I have an x and I have a 5. If a number is positive or an expression is positive, I don't need to write a plus sign. If I want to, I can, but it's not necessary at this point. Now I fill in each of the squares inside by multiplying the number or expression on top of the column and to the left of the row. To fill in this top left box, I'm going to do 2x times x, which is of course 2x squared. To fill in the top right, I do negative 3 times x. Negative 3 times x is negative 3x. In similar fashion, I'll get the bottom left to be 10x, 5 times 2x, and the bottom right to be negative 15, negative 3 times 5. Now I just have to put these four things together. When I put these together, I'm going to take them and add them. Now if they happen to be negative, like the negative 3x, I can subtract them, because subtraction is just the addition of a negative. So I will take each of my four terms and write them like this. Now I just combine to see what like terms can be put together. 2x squared stays as it is. Negative 3x plus 10x becomes a positive 7x. And then I'm left with a negative 15. And that will be my final answer. You could actually have used any of the methods we've used so far to do any multiplication of polynomials. This next method is specifically for a binomial times a binomial. And this method is called FOIL, FOIL, which stands for the first terms, outer terms, inner terms, and last terms. If I look at my two binomials, 2x plus 1 and 3x minus 5, I can label each term in each binomial as either first or last and outer or inner. For example, in 2x plus 1, 2x is the first term, meanwhile L is the last term. In 3x minus 5, 3x the first term, negative 5 is the last term. Now as a big picture, I see that 2x and negative 5 are the outer terms. They're furthest from the middle. Meanwhile, my positive 1 and my 3x are inner terms. What I'm going to do is I'm going to multiply each matching pair and then combine my four answers. The first one that I have to look for is my f. My f is going to equal 2x times 3x, because that's f and f. Well, 3x times 2x is 6x squared. You multiply the coefficients and you multiply the x's. Next, I have my o's, my outer terms. And so that's going to be 2x times negative 5, because that's o to o. 2x times negative 5 is negative 10x. Next, we'll take the inner terms, I. I connecting to I is a positive 1 times 3x, so a rather convenient 3x. And finally, I have my last terms, my L. The L goes from the L here to the L here, and that's going to be a 1 times negative 5, which is just negative 5. Now, similar to with the Punnett square, I'm going to take these four things and combine them. So this is going to equal 6x squared minus 10x plus 3x. I can combine those automatically and just make that minus 7x. And then I have nothing that my minus 5 will connect to, and so that's what I'll tack onto the end. And 6x squared minus 7x minus 5 is going to be my final answer. That's the method called FOIL. It's exactly the same as the others. It's just a specific way to help us remember how to solve the problem when it's a binomial times a binomial. Alright, let's step it up just a little bit. Now we're going to have a binomial times a trinomial. Any of the methods that we've talked about, except for FOIL, could be applicable here. We could use the distributive property and keep x plus 5 together, multiply it by each of these three, and then distribute again. We could set it up vertically, like a typical multiplication problem with 2, 3, or 4 digit numbers. We can use the table to set it up. And in fact, that's the one that I'm going to use because I think that that really helps me organize all of my information very well. When I had a binomial times a binomial, I used a 2 by 2 square. But now that it's a binomial times a trinomial, I'm going to use a 2 by 3 rectangle. And so this is going to give me the opportunity to put my information where it needs to go. You'll notice that now I have to make sure that I put everything in the right spot. The x plus 5 is my binomial, so that's what's going to go on the left side of my rectangle. My x squared minus 3x minus 2 is my trinomial, so each of those terms goes above the 3 columns on top of the table. Now I fill this in just like I would a Punnett square, even though it's no longer a square, let alone a true Punnett square. To fill in the top left, x times x squared is x cubed. And then I'm just going to go across here. X times negative 3x is negative 3x squared. X times negative 2 is negative 2x. X squared times 5 is 5x squared. 5 times negative 3x is negative 15x. And 5 times negative 2 is negative 10. Now that I have these 6 terms, I want to combine like terms by adding together what I can. All that I'm going to end up with here is an x cubed, and then I look at my x squareds and I notice that these two are like terms, so negative 3x squared plus 5x squared is a positive 2x squared. Then for my x's, I have these two are like terms. Negative 2x and negative 15x make negative 17x. And then I just have one constant term, negative 10. And that is going to be my final answer. My suggestion at this time would be to go back and look at all the previous examples and attempt to use a different method to evaluate the product. Check that answer against the answer that we got. It should be exactly the same. That's the best way to practice this, by using all of the different methods available to you.